I know they love it. I'm already grounded until school's over.
All right, so here are the answers for you to check. Which I think there might be a mistake on this, but I'll fix it.
What's 105?
We started with 81. I'm just drawing a line where like the page ends, just to help you maybe. Oh, and I have 90 on here twice. Very nice, Mrs. Bennett. All the way. And then we'll go over the open-endeds. Keystone's a week away. Monday, Module 1. Tuesday, Module 2.
Sure, everything cheat on it.
Bless you.
Thanks.
Bless you.
Thanks.
You're welcome.
Yeah.
Huh?
Yeah.
Okay. Patrick?
I was just gonna say that. See, Monday and Tuesday I won't be here. Well, I just take in the afternoon once I go.
Yeah, they'll schedule you for makeups in the afternoon.
Okay.
Or usually when the makeups
Wait,
are.
does that mean the literature one's on next Thursday?
Literature will be Wednesday and Thursday. Bio will be Friday and Monday.
Ew. Biology.
Wednesday and Thursday.
I have questions.
Okay, we're going to go over questions, but first of all, let me just speak briefly about the Keystone. So, Module 1 historically takes students longer than Module 2. Okay, so when you take Module 1, some of you will need perhaps extended time, and you are given as much as you want. Okay, but you can't leave and go eat lunch and then come back and finish it. You just have to keep working. So they will move you into a separate room for extended time, and you can take till the end of the day if you want to. Okay, not that you want to, because that would be a long time on school.
That's what it does.
But they do have to allow you that time. So just realize Module 1 is significantly, students usually think it's harder and longer. Module 2 seems to be students finish faster. It is the same number of questions, but Module 2 has a lot of mean, median, and mode, like range, stuff like that just takes less time, I guess. You get to use a calculator on the whole test, so you should be bringing your graphing calculator with you next week, and I'll remind you of that. I do have the rooms in case you don't know where you're going. I'll be posting those up probably today after school, so you can see. So we're going to break it down this week. Monday and Tuesday, we're going to review Module 1. Tuesday and Wednesday, we're going to review Module 2, and I have packets associated with those. Also, that'll be something good for you to study, like right before you go in, to look over that Module 1 packet before the Module 1 test. So I broke it up that way, so it's good for studying. I think that's it in terms of the Keystone. All right, let's go through. Starting off, what questions do we want to go over? I'd kind of like to go in order, but I don't know if that's possible. Abram?
Number 91.
Number 91.
I have one before that.
Oh, well. This isn't going to work out. All right, number 91.
Hey, that's my question.
Interquartile range.
Yeah, I need to know.
Yeah, okay. So that's Module 2. But we'll review it today anyways, but I am going to go through this like kind of like little note examples on Wednesday and Thursday. So the first thing that you want to do for anything with interquartile range is you want to order your data points from least to greatest, okay, which I have done already. So we'll have our 398, 421, 442, 464, 486, 505, and 524. And typically the Keystone does not put stuff in order from least to greatest, so you'll have to do that on your own, unfortunately. Okay? Now, the quartiles, what they're talking about with quartiles, all relate to your box and whisker plot. Okay? Which look like this. Okay? The whiskers, this is your minimum value, and this is your maximum value. Does anyone remember what the middle line is? The median. Okay, the median is also known as quartile 2. We just never call it that, but technically it is quartile 2. Now the edges of the box, this is known as quartile 1. This is quartile 2, so that makes this quartile 3. Okay? Now to find the quartiles, you find the median multiple times. All right, so we have our data in order from least to greatest. Find the median. We find the median by crossing off the largest and smallest values until we find the middle value. So the median is 464. Okay. Now, to find quartile 1, you're actually going to find the median of the bottom half. So of the bottom half of data and the top half of data, we find the median of those two sides. So you basically find the median 3 times. Once in the middle, once at the bottom half, once at the top half. So we cross off the smallest and the largest number, so 421 is my quartile 1. Of the bigger half, 486, 524, so 505 is my quartile 3. Okay, the interquartile range, just like range is large minus small, right? Large minus small for range. The interquartile range is to subtract the larger quartile minus the smaller quartile. So you'll take quartile 3, which was 505, and you'll subtract what you found for quartile 1, which was 421. And we do get answer choice B, which was 84. Now, again, we're going to do a lot more practice with those on Wednesday and Thursday. But also remember, quartiles are called quartiles because they're quarters. So what they do is they break the data up into 25%, 25%, 25%, and 25%. So while we're here talking about the quartiles, if you look up at 89, that one also had information about quartiles. So it had told you that the median was 62. So if you're thinking about your box and whisker plot, my median is 62. Now it also tells you the interquartile range is 32, which is telling you if you subtract this from this, you get 32. Unfortunately, that doesn't give you enough information to know what those exact numbers are. So this was what we call extraneous information. It was there to trick you. Okay? So really the only thing you need to know is that the median is going to cut the bottom half of data will be 50% and the top half of data will be 50% because the median is the middle. Okay? So the answer choice for this one was C. Approximately 50% of the days had a high temperature that was less than 62. Okay, so I figured we'd talk about that one while we were talking about the quartiles as well. Brooke, what was your 89? Oh, it's like I read months.
Yeah, I got another one.
Another one?
Yeah. Basically all probability.
All the probability ones, I figured we'd go over those.
It's 101.
Okay, so 101. So first of all, remember that probability can be found by taking the number of favorable outcomes over the number of total. Okay, which probability in interquartile range, etc., that's all on module 2, okay, in terms of the exam. So this one says you're rolling a number cube twice. What is the probability that the sum of the numbers is 3? So how could I roll the sum to be 3. A 2 and a 1, or a 1 and then a 2, right? So that's 2 possible outcomes that will get me what I want. Okay, because I could do it the other direction. So I have 2 favorable outcomes. Now, some people will be like, I have 6 total possible. That's not true. Okay, one way to figure out how many possible is to actually list them all. So I could get 1 then 1, 1 then 2, 1 then 3. Or I could get 2 then 1, 2 then 2, so on and so forth, continue all of them. You'd end up getting 6 by 6, which is 36. Okay. The other way to do that is to think about when you roll the first number cube, you have 6 options. When you roll the second number cube, you have 6 possible outcomes. So that will get us a total of 36 total possible combinations. Then I reduce that fractions. 2/36 reduced to be 1/18. Okay. 102, which I should also mention, these were dependent events. Like if you rolled a 2 on the first one, you needed to roll a 1 on the second one for it to add to be 3. So like it depended what you got first to see what you would need second, okay, in terms of what they wanted you to find. Now on 102, these are independent. You are answering a first multiple choice question and a second multiple choice question. They have 4 choices. What's the probability that you answer the first one correctly? There are 4 answer choices. How many of them are correct? 1. You only have 1 correct answer, right? So the probability of getting the first question would be 1/4. Second question has 1 correct answer and 4 total.
Please go extension 6501.
What do I do with those? Add them, subtract them, multiply them, divide them? You multiply them. So you find the probability of your first independent event and the probability of your second, and you multiply them, we get 1/16. C. And then 103 was similar. We were flipping a coin. We wanted to get heads, so that's 1/2. And we want to pull a green marble from our bag. So there are 5 green marbles, so that's the favorable. Out of 5, 6, 7 plus 4 is 11, so I have 11 total marbles. So 5 11s, and then we multiply. 1 times 5 is 5. 2 times 11 is 22. So just A. Next one. I would have thought some of you would have got the linear ones wrong just based on not reading carefully. For example, 87. So I would have ventured to guess that a lot of people would have thought the answer was B, because the y-intercept is 1 and it goes up 1/1. Why is it not B? Well, it tells me that this is bushels of green beans in thousands. So when it has a y-intercept of 1, this is actually a y-intercept of 1,000. Okay, so I'm going to eliminate answer B and answer C because those actually say 1. So if you don't read carefully on the Keystone, you might know what you're doing, but get the wrong answer. Okay? This is in thousands. So this is 1,000, 2,000, 3,000, 4,000, 5,000. For the slope, it looks like it goes up 1/1. So a lot of people would pick A. But again, it really goes up 1,000 and over 1. So my slope is 1,000 bushels per inch of rainfall. So the answer for that was D. There were quite a few questions on the packet that you had to pay attention. It said in thousands or in hundreds for the way they defined their axes. Other ones? Stuff? 96. Okay, so 96 had said what is the range of the data, which we know like domain and range are one type of range. When you're finding the range of the data, that's when you take the largest value minus the smallest value. And for a stem and leaf plot, you basically just attach the stem to the leaf to get the whole number. So the largest number would be 7,538. The smallest number would be 7,493. And then all I had to do stuff was subtract those. Usually, all the sample questions I've seen for the Keystone, they usually have a key too to tell you like Like they'll tell you what it actually represents in case it were sometimes you can use a decimal point for a stem and leaf plot too. But you just want to make sure that you didn't use like 7,499 as your smallest, because the 3 is smaller than that. Next one, Abram?
Did you do limit 2, limit 3?
Are those open-ended?
No.
No. Yeah, I did. You can watch the video. We still have to get to the open-ended though. Other multiple choice before we get there? We want to go over. All right, our open-ended. Number 104. A lot of people will tell me that the mistake is in step 2. That is incorrect. It was step 1. Okay. Some people look at this and say, oh, they did 25 to 25. This should be 5, that is an error. Okay. But the major error is that they took this number and they broke it up into 2 numbers that add. If you're breaking up a square root, you break it into 2 numbers that multiply to get you the square root. So you should not be, this is incorrect. You should have broken 125 into square root of 25 times the square root of 5. Then we would take the square root of 25, which is 5, so my answer was 30 square roots of 5 for the correct answer in part B. Sometimes these error analysis ones, like you know how to do the problem, but when you look at their wrong work, you don't realize what they did wrong. So I highly recommend just like doing the problem off to the side and then looking back at the work. So the error was in step 1. And that's what the correct line of work should have looked like. Okay, we went over the perimeter and area one pretty much. You would just add up all your sides for the perimeter. For the area, you did need a FOIL, combine like terms. You could use the perimeter formula, 2L plus 2W also. And then for part A, how many hours did you get until they have $51?
6.
6, very good. And then how about how many hours until they earn the same amount?
3.
3, very nice. Okay. Other ones from the packet before we take a look at today's review. Okay, did everyone pick up this paper on the way in? I think I have a lot left. You need them? Okay. So today's module 1, day 1, just like I picked some key topics, things that you might need to review. I'm not saying we need to go through every example on here. I feel like some of these things you already know how to do. We don't need to review them, but I put them on anyways, in case. All right, GCF. The only reason I put a GCF question on here is because I also put least common multiple, and I want you guys to understand the difference between the two. What would the GCF numerically be between 27, 3, and 9? What's the largest number that's divisible into all of them? 80? 3. Okay. Remember, a GCF is a common factor you can divide out of each. Yes?
I thought you could put...
That's just the number part.
Okay.
Then we'll do the variables. Okay, now we want to look at each of the x terms. We have x squared, x to the 4th, and x cubed. What is the greatest common factor between those? Abram? X squared, very good. So you do take the smallest common exponent. How about your y's? We have y cubed, y squared, and y. So we could take a y. And then we also have z's, and 2 of them. Can we take a z out of the third one?
No.
No, because there is no z there. Okay, so it would not be a common factor. Okay, so that should be easy. The least common multiple is what some students forget how to do. Okay, so I put an example on here that has all numbers. Okay, and it's worked out for you. So if you were asked to find the least common multiple between 8, 4, and 6, you're saying, what is the smallest number they multiply to get to that is the same? So look, they listed all the multiples of 8, not the factors of 8, the multiples. 8 times 1, 8 times 2, 8 times 3, and so on. Listed all the multiples of 4, multiples of 6, and you can see that the least common multiple is 24. Now, when is this useful? Why do we find the least common multiple? Fractions. If you were to take this and make it 1/8 plus 1/4 plus 1/6, you would be using the least common multiple to find a common denominator, right? Okay, so if you were doing this, you could multiply this one by 3 to get 24, this one by 6 to get 24, and this one by 4 to get 24. So if it helps you, you may want to change them to fractions, and then you'll realize like what the least common multiple is. Some students see it a little bit more clearly, but the harder part comes in when we have variables and exponents. Okay, so the least common multiple between 2 and 3 would be 6. So essentially, again, you're thinking of the smallest number we can multiply to get these numbers to match, to be the same number. So I can multiply this one by 3 to get 6 and multiply this one by 2 to get 6. Now when you compare the variables, you're actually going to take the larger exponent. Okay, and the reason for that is that you can multiply this one by x to get it to become x to the third, and then it would be common. Okay. In terms of the y's, I can multiply this one by y to get y squared so that they match. So y squared would be part of my least common multiple. And then the big debate is whether or not to put the z there. Okay? Again, if you're thinking of a fraction, if I just took these and put them as fractions with this in the denominator, okay? If I wanted to make these common denominators, this one has a z, this one would have to have a z also. So you do include the z. Okay? So it doesn't have to be common to both terms for the least common multiple, only the greatest common factor. And I do highly suggest, if you think it's confusing, to set it up like this, and that should help you to realize like how you could get the denominators to be the same. Okay? How about the next one? What would our least common multiple between 4 and 6 be? Just the number? No? 12. Very good. A lot of students say 24, which is wrong. That is a multiple. It's not the least common multiple. Okay? And then again, we're going to take the larger of the exponents. So we're going to take our x cubed, and we're going to take y to the 5th. Okay? That was in one of the packets that some of you guys asked about. See if you guys can try numbers 1 and 2 on the simplifying radicals.
So basically, when you find a number for the variables, all you do is take the bigger one. I like no.
This better.
Mm-hmm.
It's so easy.
You can use that on the test.
On Keystone?
Mm-hmm. He has this calculator that simplifies radicals for him.
We just get, I think we get anything.
All right, what did you break 98 down into?
Can I bring in 2 calculators?
You can bring in as many calculators as you wanted, yes.
That's in your.
All right, what do I break 98 down into? Ryan, since you're talking.
7 and 8.
7 and 2. 7 squared is 2.
49 and 2. Then we take the square root of 49, which is 7 square roots of 2.
Next one's 3 squared is 2.
Yes, it is. We would need to rationalize, because you can't divide these. We'll get 6 square roots of 2 over 2, and then we'll divide those to get 3 square roots of 2. Okay. I don't think we need to go through all the radicals. It hasn't been that long since we did them. So,
Can you just tell us the answer?
I don't have one by.
I was syntax error for saying good.
This one would be 50.
Yeah.
20 square roots of 3.
How do you do
Number
number 3?
3. You'll square each term. So this would become 5 squared times the square root of 2 squared. 5 squared is 25. The square root of 2 squared, those undo one another, just leaving me with 2. And then I multiply to get 50. Abram?
Oh, wait, no. Yeah.
Mm-hmm. Did you guys want the answers for these ones too?
I didn't know yet.
Well, this would be 6 square roots of 2. 2 square roots of 2. 4 square roots of 3. Come in.
me.
And 77.
Alexander.
Okay. Exponent rules I just threw on here for you to reference. Okay, remember your negative exponent rule dips to the denominator. If you're multiplying, you add the exponents. If you're raising a power to a power, you multiply. And if you're dividing, you subtract.
Is that on the sheet?
It is not on the formula sheet. That was on the Algebra 2 one,
That's what it was.
but it's not on the Algebra 1. So yeah, I guess it was on the one I just gave you.
Do we get
Alright.
formula sheets?
Hmm?
Do we get formula sheets?
You get the Algebra 1 formula sheet, which was like the front of the final formula sheet.
Is that quadratic formula?
No. You don't need quadratic formula for this
Oh,
system.
nice.
Okay. I'm going to skip adding polynomials. Do you guys remember if you're adding, you just end up combining all your like terms?
Yeah.
Okay. Subtracting, what do you have to remember to do? Distribute your negative. Okay. Remember, these are different from multiplying. So if you don't see a sign in between them, that's when you're multiplying. So foiling or mass distributing with a binomial and a trinomial. Okay. Factoring. Hopefully we remember how to factor. What would this factor into? X plus what?
X plus 4 is 4. X plus 4 squared.
No.
I mean, X
plus
plus 4
2,
X plus 6.
4 times
Oh, no,
3 is
it's
12.
the-
4 plus
X
3 is
plus
7.
2, X plus 6, X plus 2.
Right.
2 and 6. Thank you. Numbers that multiply to 12 and add to 8. They do only put easy factoring ones on there, so you don't have to do the guess and check method even. They'll just be these easier ones. Now, the one thing that is a little bit harder are the rational expressions.
There's
So,
more work.
question. Can I just do this?
No.
Probably not. Why not?
Because it's not.
I feel like you could.
Because
but
this is
it-
addition
make it
and this
hard.
is division, and those are not off inverse operations. So anytime you see an addition or subtraction in a fraction, you probably want to group it to remind yourself you cannot just cross stuff off. Okay, so what we're going to do is we're going to factor the top, which Abram, this one would factor into what you said last time. 4 times 4 is 16. 4 plus 4 is 8. So we'd have x plus 4, x plus 4, 4x plus 4 squared. Now in the denominator, I'd want to factor numbers that multiply to negative 24 and add to negative 2.
Negative 6. Negative 6.
Negative 6
Oh.
and 4. Again, you might need to list your factors. And then obviously one of them is negative to multiply to be a negative. And then we can divide out our common binomials. Okay? I'd like you guys to try the next 3 examples, which are multiple choice, while I pass out your homework. Okay? The homework tonight, you are only doing numbers 1 to 14 and 31 and 32. So 1 through 14 are multiple choice, and then 31 and 32 are open-ended.
I can't read this.
Yeah, well, I believe so.
6 times e to the 4x.
Oh, that's an E.
Yeah. And then the minus 2 is like at the end. It's not part of the exponent. This whole thing has. You're only doing numbers 1 through 14 and 31 to 32, so you might want to jot that down. I just went over the It's on the board. Sorry. Come in.
Are you done with
No,
Okay.
not yet.
Okay, I'll come.
I
can
can
see
see
it.
Wait, where are you
All
going, Red Rock?
What did you get for number 7? Number 7? A. We should have factored the top into x plus 10 and x minus 3. And we were able to divide those out, getting us answer choice A. How about number 2?
A.
Also A. You should factor out 3x from the top Okay, and then you are able to divide the 3x with the 3x. Ooh, forgot to divide that one. And B, very good. Factor out a -1 in the top. And then the denominator will factor into x minus 16 and x plus 15. Which whenever we divide out our common binomials, we're left with -1 over x minus 16. Alright, so again, homework is numbers 1 through 14, 31 and 32, the Module 1 packet. If you feel excited about the Keystone, if you want to do more problems in the packet, go for it. No, because they'll be assigned tomorrow.